So thank you all for being here today. My name is Alyssa Duritz, and I was one of the organizers of the event. So as you can see, this is going to be a hybrid workshop. We have our in-person and our virtual attendees. So I am the soil health coordinator for Linn County Soil Conservation, and I am out of the USC Service Center here in Marion. And I'm focused on increasing conservation, soil health, best management practices in the Indian Creek watershed, which we're in right now. And so that includes putting on workshops and field days just like this one. This is actually the first one that I've helped organize, so thank you for being here. You've had a pretty good turnout. And I'd especially like to thank my co-organizers, Evan Brame and Helen Leavenworth, who isn't here today. And we'd also like to acknowledge all of our partners with Linn County, the Soil and Water Conservation District, the Indian Creek Watershed Management Authority, and the NRCS for helping support our event today. And thank you to the Solid Waste Agency for loaning this wonderful conferencing camera and our Zoom account today. And to the City of Marion and Steve Cooper for providing this meeting space for us. And to the Iowa Soybean Association for providing the great coffee and donuts today. And thank you all for being here to learn about soil health. So we can preserve what we have and build upon it for the future. And I think Evan mentioned this, but make sure that you sign in on the sign-in sheet if you haven't already. John's holding it up in the back for us. There are also CCA credits available. And there is also a evaluation form that you can fill out at the end of the meeting if you would like. We would really appreciate it to get feedback for our future events. And I will be mostly on the computer monitoring the chat if there's any tech issues with that. And there are bathrooms both that way and that way if you need it. And so first we're going to have Evan talk to us about an overview of why we're here today. And then we will have our guest, Dr. Rick Haney, join us via Zoom to talk about the Haney test. And then we also have some other NRCS staff available to answer any questions and talk about potential cost share programs. So without further ado, I'll hand it over to Evan.
All right, well, thank you, Alyssa. Pleasure to be here today. Unique opportunity. I won't take too much of your time. I just want to talk to you about what Iowa Soybean Association is doing, specifically right here in Eastern Iowa, and how we can, increase conservation from a environmental water quality perspective, but also agronomic perspective. So thank you, Alyssa, for the introduction. My name is Evan Brame. I'm a conservation agronomist with Iowa Soybean Association. Here's a map of all of the conservation agronomists who are employed by ISA. So I'm the Lone Ranger here in Eastern Iowa. I have been the last one hired. So just to give you an idea that these positions are gaining momentum, there's no reason to explain exactly what a conservation agronomist is by definition, because there's a lot of different definitions out there. But what I want to leave you with is we are working directly with ag retail partners and their customer base, but also NRCS staff on how we can increase conservation right here in Iowa. So for those that think, for the most part, a lot of us are from Eastern Iowa, but you can see if you have any friends or family, if they are interested in collaborating with ISA or even a local retailer, we do have several conservation agronomists throughout the state. And this is just our direct staff at ISA. There's also what we call our Conservation Agronomist Network. Heartland Co-op has several on staff, as well as several private companies have conservation agronomists on staff. So I apologize for those that were at our meeting last week. I did recycle a few of these slides, but I actually got good feedback on this one for once. So I wanted to show this one again. And so people always ask me, why does Iowa Soybean Association care? Why do the ag retailers care? Well, I made this umbrella, and what I look at it is a way where we can increase conservation in agriculture. And there's all of these partners involved. Now, conservation is different for everybody. Whether you're a farmer, if you're an ag retailer, if you're a government agency, a nonprofit, there's a lot of definitions. And so I included underneath this umbrella of all of our partners, various conservation practices. Nutrient stabilizers are the big ones. This is kind of where I started to get involved in conservation, how we can conserve the nutrients that we're putting out there. So from an ag retailer perspective, what products are we using? How can we stabilize our nitrogen? How can we stabilize our phosphorus? Reducing erosion is a big one for conservation. Cover crop adoption right here in the Middle Cedar watershed. There can be some great opportunities through the RCPP that growers will get paid to adopt cover crops on their acres. Crop scouting, a great way to get out there and see what's going on in your field and make those best agronomic and environmental decisions. Maybe you don't need a fungicide. Maybe you don't have the disease pressure. Maybe let's pull back and use that elsewhere. Improving water quality. That's a big one, especially right here in Marion and Cedar Rapids, where we talk about where we get our drinking water source from the Cedar River. And as an agronomist, I also want my farmers to adopt these practices, but also maintain and improve your yields. We often talk about yield drags and how we can overcome those, and there's a lot of management we can do that through conservation. And then instilling confidence in our ag retail partners and our farmers that the conservation practices they're making are going to help them. Bringing them to cost share, there's a lot of partners involved with this. ISA is one, NRCS is a big one. City of Cedar Rapids really promoting cost share programs. Being profitable, farming is a business, and if you're not profitable, you're not going to be farming much longer. So we want to be able to find profitability in conservation. Then also creating a positive image. And this positive image is this picture here. We had a Clean Water Wednesday with the big show back in August at O'Connell's farm, where he installed a wetland project right off of E Avenue in Linn County. And this is a wonderful way with all these collaborative partners that I just discussed. So I'm pictured here along with Mary Beth Stevenson from Cedar Rapids, Andy Peterson from the Big Show, Jim O'Connell himself, the farmer, installed the wetland, Ron Wasty, general manager at Linn Co-op, a retail location, and then also Sean McMahon with IAWA, the executive director. This was a great day. I know we had some farmer friends out with us as well to attend this and really promoting a positive image of what we're doing in agriculture, but also conservation. So for you NRCS employees, it's probably not a new image. You probably know these watersheds better than I do. But I often get the question of, okay, Evan, what's your territory? What are you trying to accomplish? So really what it comes down to is this the Middle Cedar watershed. So this encompasses 1.5 million acres. Of that, about 75% are row crop acres. We have 3 large cities, Cedar Falls, Waterloo, along with Cedar Rapids down in the lower corner there. A lot of farmland, a lot of agriculture. We're the #2 state in agricultural production. We're going to have agricultural products. But what can we do to improve water quality in these areas? And that's exactly the things that ISA is working on. And I'm not, we're not limited just to Middle Cedar, but this is where the RCPP funding is, there's a big focus there. What's RCPP? Yes, RCPP is an NRCS program. It's a Regional Conservation Partnership Program. And so the city of Cedar Rapids in about a month, no, a couple weeks, 2 weeks from now, we'll have a big public meeting about that. So there's more to come on that. The big RCPP is in the north. There's one in the North Raccoon as well. So Middle Cedar watershed has a lot of cost share funding coming to adopt conservation in this area. So this is Middle Cedar watershed. Just to give you guys an idea of of the focus that I have. I won't get into this too much, but people ask, why? What about water quality? Why does the city of Cedar Rapids care? Well, they draw their drinking water right from the Cedar River. I won't talk a whole lot on that. I know there's a lot more people that are a lot more knowledgeable on how all that works, but just understand that the Cedar River is in the Middle Cedar watershed, a lot of crop ground, a lot of water goes directly to drinking source. So this is why the city of Cedar Rapids really cares. And this is why working with ag retail, with NRCS is really important in connecting all those pieces and conserving the nutrients and the products that we put out there. So here's a few things that I worked on farmers with, and this picture is actually in the Indian Creek watershed, not that far away from here. So the upper corner, you can see the brown is cereal rye cover crop. So it was planted in the fall, and then it was strip tilled with anhydrous ammonia and dry P&K. And it's also next to a saturated buffer, which is a great edge of field conservation practice. These are real life situations that I deal with and we're promoting to our farmers, and how we can conserve our nutrients that we put out there if they so choose to do synthetics, but how can we reduce that erosion and also keep those nutrients in the field. And then this is a great example of chemical termination that we worked with an ag retailer partner on, and we had the benefits from the cover crop being out there, but also able to control it. Down in the lower corner, this is a little bit of a different setup. This is corn planted green, so it's planted into about 3-foot tall cereal rye. I was involved on a research project with this, looking at how we can conserve our water in our fields. And so I installed water sensors in the cover crop, and you can't see it, but both sides of this, there's no cover crop. And it was dry, and it was hard to drive those probes down in the ground. But it was interesting to see nonetheless. And we're also looking at nitrogen management as far as corn goes, because farmers get apprehensive about planting green into cereal rye. So these are things that ISA is working on to help farmers adopt cover crops. I don't have livestock, maybe that's why I like them, but I enjoy talking to my farmers about grazing cover crops. So here's some good examples of it. The upper picture is standing corn. You can see a cover crop growing in between the rows. Anybody have an idea of how they got that there? How would you get that to look like this by the end of September? Any options for farmers? What would you do? Aerial application is a good one. Yep. Through a plane, through a drone. This one was, yep, that worked too. Yep. Sprayer going, yep. Your hoses down between the rows, absolutely. This one was actually put on in early June with an air seeder and a rotary hoe from Montag. So they're a large row crop and cattle operation. They wanted to find a way to establish a cover crop sooner. How can we do that? So these are options, these are things that I help my farmers with, and I'm also learning right alongside of them. But a 5-way cover crop species mix, harvested it in September, great growth, great opportunity to graze. Then we got a picture of some friends of mine north of Troy Mills. Underneath the cattle are actually wheat that was harvested for small grain, and then cover crop drilled out there. As far as the regenerative agriculture goes, you're looking at it right here. And integrating your livestock after small grain, putting a cover crop out there, they're producing manure, urine, a lot of nutrient benefits from that. I'll put a plug in here for a really cool project we worked on with IAWA, so Sean McMahon, and Iowa Soybean Association, and then also Exile Brewing. They made a Born Here, Brewed Here beer. It was a rye IPA, volume 1. I'm really excited. Volume 2, I think Iowa farmers are really going to enjoy. But the idea here is to work with the consumer. And they're looking at agriculture and again, that positive image of things that we're doing. So they promoted this, they promoted water quality, they promoted cover crops, small grain harvest. And that's my friend Mike walking out in the rye that was actually put in this beer. So a really cool opportunity and things that we're working on to promote conservation and even small grain harvest for that matter. And the upper picture there came from KCCI. They did a whole news story on this. I know for us locals, Coggin is spelled wrong, but that's beside the point. But what this shows is where the grains came from, where the hops came from. It was also malted in Cascade. I don't see him today, but Eric Miller, he has a malt house up in Cascade, also a farmer himself. But he was going to try to make it. We had him talk on that, but that's fine. But nonetheless, a really cool project, again, creating that positive image and things that we can work on with farmers and even creating alternative markets. In Western Linn County and Eastern Benton County, I'm working on, in collaboration with several of our partners, a conservation in action tour. This is allowing the public and anybody to come out and see, hey, what we're doing in these areas as far as conservation goes. So this is a self-guided tour, and I'm gonna run this probably starting about April till about June, working on getting some field signs displayed, and there's some Jim and Dan's fields over here. So if you wanna know how to implement conservation, these guys can tell you how to do it. But on this route, there's several different methods of cover crops being applied with an airplane, with a drill, several different species. There's the wetland project, pollinator plot, and then there's a dairy in the area, looking at how they chop silage, put rye in behind that, a great conservation practice. So stay tuned on this. We're going to promote this. I really appreciate the Linn County Soil and Water Conservation District for helping with the funding on this project. So they're going to promote this as well. And along this tour, again, self-guided, if you stop and take a picture, the local brewery in Atkins, they've chipped in and they're willing to give people $1 off a drink or $2 off pizza and pretzels. So again, connecting that producer and consumer and creating a positive image of the things that we're striving to do. So stay tuned for that. I'm really excited to kick this off. The posts are out there, but there's no signs. So we do have Rick on the line, and I'm not going to take anything away from him, but the reason why we're here today is to talk about the Haney test. As a conservation agronomist in my past occupation, I've taken thousands of acres of the Haney test. I've seen that this works. And working with farmers and ag retailers, if they're looking at how to implement soil health, I mentioned several practices under that umbrella that we can do. But the Haney test takes a step further, and I've personally seen this myself. And really, what can you do as a farmer, as a consultant? You can do this yourself. If I can do it, you can do it. In this picture is all the tools that I have. So I have a bucket. I actually have 2 buckets because I was taking 2 different depths. I was doing 0 to 6 and 6 to 12 to get regenerative certification. But you can get soil probe, some soil bags, and preferably a form of transportation. So I had a gator there in the background. But you take your samples, you figure out your baseline, then you send it to the lab, Region Ag Labs, who Rick works for. That I've sent pretty much all of my samples to Regen Ag Labs. Then you receive these results. And what's great about these results is it tells you exactly what's going on out there. Now, in my past, I typically focused on 2 metrics, which was soil organic carbon and soil organic nitrogen. And those are big ones of what the Haney test can really do, but there's about 60 different metrics on this test. Then you receive your results and you can make management decisions. This is where I've seen it help my farmers. We've been able to cut down or better utilize our nitrogen applications. I have growers that are completely, not using any synthetics of any sort, and then some farmers who are looking at ways to better utilize those nutrient resources. So who can do this test? You can do it. Regen Ag Labs will give you the results back, and then Rick is obviously a great resource, but Lance Gunderson, who owns Regen Ag Labs, knows the test, and Rick will probably say that just as much as he does too. So they're great resources. And for those that were at the Big Soil Health event, I know Rick spoke and then Lance spoke, and there's a lot of excitement around hearing both of those individuals talk. So that's kind of what I wanted to talk about here today. Conservation-wise through ISA, things that we can help farmers do. We have a bunch of trials we're working on. We have an advisory meeting tomorrow, working with farmers in eastern Iowa on cover crop strip trials. So a great opportunity to, what can we do to help our farmers yet have that data to back it up. Here's my contact information. I've really enjoyed working with all of these individuals some of us are here with us here today. I'd be happy to help you. And if you're looking to adopt conservation or just looking for resources or opportunities for future events, Iowa Soybean Association would love to work with you. So thank you. Any questions from anybody?
Okay, well, thank you, Evan, for that. And now we're gonna have Dr. Rick Haney speak to us. I think he might have a presentation here. So Rick, if you're there, you're welcome to go ahead.
I'm here. Can you see me? Can you hear me or see me?
You're good.
I can't hear any. Yes? Okay. Giving these webinars is weird sometimes because, you know, it's hard to have any feedback and understand what you're looking at. But anyway, I've been retired from USDA for about 1.5 years now, which is pretty strange. So I wanted to show you my new office. This is my barn. So there's my latest project is a 49 Chevy pickup I'm trying to put together. There's my computer screen. So this is a much more relaxed area than working at USDA, I can assure you. So do I need to just share screen here?
Yeah.
Yep. All right. There it is.
We like your name, Rick.
Yeah. So as Evan said, I'm working for Regen Ag Labs because Lance was the first guy to really see the Haney test and understand it and make it happen. And he's really an excellent resource, as Evan said. And he's quite a bit smarter than me. He's not as pretty as me, but he's very intelligent. But I wanted to give you a little background on where this all came from. And if you guys have questions, you know, just get right in there because I've seen this stuff. But I gave this talk in Iowa, and the Haney test is actually a set of soil methods built for farmers by a farmhand, because I started working on farms when I was 17 till about 25, till I was about 25 years old full time. And then I was kind of on those farms off and on after that for another 10 years probably. So I came from a different perspective. When this picture is when I was in graduate school. I was probably 39 or 40 when this picture was taken. So, and this test really started when I was in grad school. I didn't know it at the time. I was just doing my research, and you know, things just kind of fell into place. And so, one of the things we want to do is understand that, you know, we live on a plant-based planet whose life is driven by a star. So, the sun provides energy. The plants use that energy to pull in CO2, you know, make a plant work. And, you know, it's kind of magic. But sometimes we lose perspective. We just think, oh, we just throw seeds in dirt and here we go. But it's an absolutely complex system. And so what we really want to do is capture as much sunlight and get that energy in the soil so that we can assemble carbon complexes and, you know, grow plants. But there's a whole big dance that happens that we are unaware of, that between the microbes, the plant roots, you know, and there's a lot going on there that we just haven't ever accounted for or really looked at. So the other fun thing, and when I did my PhD dissertation, I had a bunch of references in my dissertation from the like 1890, 1910s, 1920s. And when I submitted it to the graduate school office, they called me and they said, well, we're not happy with these old references. They're too outdated. And the reason is because, you know, these folks, this is a quote back in 1892, where this guy considered the soil as a botanist and not as a geologist. And that's a very important thing to understand, is that, you know, geology deals with rocks and, you know, different types and sedimentary rock and stuff, but botanist deals with life. And so understanding that the soil is actually alive is really important. And we have ignored that for a long, long time. But they knew about this way back when. So see, look at this. I mean, this is back in the cave days. These guys, you know, the dirt molecule, they had it. They were already figuring it out. This is a quote from when I got out of grad school that I came up with because I was working on CO2 respiration from the soil. And I put in the beginning, there was dirt, and in the dirt, there were microbes, and it was good. And then it rained. And I'll explain this as we go on, because, you know, this was a very interesting part of my education. So back in 94, we were looking at these soils, and soil microbes take in oxygen and give off CO2 just like we do. So we were measuring that release of CO2 from any given soil, but we would dry it first and then re-wet it. And so this is some of the very first stuff we were looking at. And these are soils from these 3 different places. And the bottom one's the best soil, you know, and the top one's the, you know, worst, I guess you would say. But if you notice, this is during the first day. So we dry this soil, add a little water to it, and cap it, and put a little potassium hydroxide trap in there to trap the CO2. So we'd wait 24 hours, and then we'd pull that out and titrate it and get the answer. And as you could see, we had this little response here in this soil, a bigger response here, and an even bigger response here. And this was really shocking to us because we were told that you had to wait 7 days. From the literature said you had to wait 7 days to start looking at soil microbial activity because you had, you know, disturbed the soil. Well, look out here at 7 days, there is nothing happening. The whole ball game was right there, and we missed it. So that was very eye-opening. So we had to publish quite a few papers to show that here's where the ball game was and not over here. So like it's raining here right now, and it's been pretty dry. So guess what? It's not going to wait 7 days to do something. It's going to do it right now. And so this was a very eye-opening time in grad school back in. So this is when this really started. This was pretty kind of the first aspect of the Haney test. And I went on to look at, this was nitrogen. So this is carbon. So I had this fancy machine that I got. It was really old, but it was an infrared CO2 analyzer. And so I was running these tests within a few hours after I'd re-wetted soils. We were getting this very strong correlation with the nitrogen release in 30 days. So we took the measurements. As soon as we re-wetted that soil, from 1 to 6 hours, got this flush of CO2. And we took those soils and left them in the incubator for 30 days and measured the nitrogen. And look at this super strong correlation here. And we were showing, so I went to publish this, and it was rejected in a paper. And I wrote there, this was their reason. They said it was too simplistic in spite of the data. And I will never forget that moment because, you know, I put Haney becomes emotionally disturbed. I'm a farm boy off the farm, coming to academia, wowed by everything. And I thought, wow, they're really going to love this. This is very interesting. We can probably help the farmers with some of this information. And this is what they came back with. No, it's too simple. Can't do that. I was so mad. It was eye-opening. But we just kept going. So this is, you know, 1 to 6 hour CO2 release from soil versus a 30-day carbon mineralization. I mean, it's just, the microbes know what they're doing. They're just in step with what we're doing. So why would we wait all this time to measure these things? We could get these measurements quickly. The reason that's important is because that suits soil testing. Soil testing lab, you guys aren't going to send a sample in and wait 30 days to get an answer. So this was exciting to me. I'm going to skip through some of this because, you know, it's not that important, but this was showing a flush of CO2 after we added chloroform to a soil, and then how it responded. And these are low and high organic carbon soils, but this is the drying and re-wetting flush. So you can see that they follow a very similar thing. So we knew that we were killing off these microbes with chloroform, and the ones that survived were coming back and respiring CO2. So we were seeing a very similar flush, but without having the use of chloroform. This is just basically from drying the soil. So another indicator that, wow, we can do this in a soil testing lab quickly. This was my PhD dissertation I talked about earlier that they almost rejected because the references were too old. But, microbial activity to assess agricultural soil seemed to be something that, was unheard of. This is the original infrared CO2 analyzer. Look at the size of that thing. We've got one about the size of a credit card now that's more precise than this one, but this is my original setup when I first calibrated the CO2 release to the Solvita paddle. I don't know if you've heard of that or not, but I did the original calibration on that. The problem that we ran into was that later was the Solvita paddle was running out of juice there. So we compared that with the infrared gas analyzer CO2, and we were getting some pretty wildly different numbers because the paddle would stop, get saturated, and couldn't go much beyond 120, 150 part per million, whereas the infrared analyzer would go up to 1,000 part per million. So we saw that a little bit later, and that's why we switched to using this infrared machine. It's just more accurate and measures CO2 directly. I show this picture. This is me in the lab, and this was my original infrared CO2 analyzer setup, because I was redneck from Western Oklahoma. So this is just how we did things. We didn't have much money in our research budget, so we had to kind of make do. But once the paddles got too expensive for us to buy, we had to come up with something else. And that's just a little device we came up with. So this is some cedar wood that I had in my shop, an old piece of plexiglass, and there's the detector. I don't know if you guys find this humorous or not. I do, and this is the backside of it. And so here's your detector, and with a little pump, and we wired it all in, and it really worked. It worked really well too. So that was really fun. So we did a comparison with the Solvita paddle in these jars. So, we have paddles in every one of these, and this is the fancier version of the respirometer that you showed a picture of earlier. So we fancied it up a little bit and made it a little bit better. So now we've got something here that works. And then we took that and shrunk it down to this. So these are little CO2 analyzers also. There's actually, I think, 5 of them put together to one jar right there. Make sure they're all getting the same answer. But that was always been fun, kind of the engineering part of developing some of this. And then here's one thing that I really miss from being retired. I'd built this system where we could look at CO2 in all these different deals, and this was all automated. We could put all kinds of different soils in here, treatments, and just turn this thing on and let it run. And boy, I wish I'd have bought that from them or something, or got that from them somehow. I sure missed having that thing. Anyway, there was a big argument about incubation time for soil respiration, from a soil testing standpoint. And again, we know that drying re-wetting flush is the microbial biomass turning over. So it's a good estimate of what's actually happening in your soil as far as the life. And we did a bunch of experiments, and we were showing this. So this is 1 to 4 days in incubation time. So you put the soil up, put it in the incubator for 1, 2, 3, or 4 days, and then get the measurements. And all this graph is showing is that these black dots here, if you can see that, that's the first day. And this was the peak of the flush. So we were measuring this so often that we could tell exactly when a soil peaked its respiration. And so this is the peak versus 1 day, 2 day, 3 day, and 4 day. And as you can see, the farther you go in incubation days, the less accurate it becomes, scattered. So that was, kind of brought home that we could do this in just 24 hours, a 24-hour test. We can measure the respiration in your soil. But then we ran into, and this is in graduate school, is CO2 respiration biological? Well, yeah, but they didn't really they were like, well, where's the evidence? So I built this little thing, which has a CO2 and O2 detectors in them. We were measuring both O2 and CO2, same sample. And so this is what you see as the O2 uptake. So the oxygen actually goes away in that jar. So you see a reduction in oxygen and an increase in CO2. So because it's taking in oxygen and giving off CO2, and here's the result. And so we showed them this and tried to get this published, and they were like, "Oh, okay, I guess it is biological." But these are the things we were running up against, and that it was because of that mentality that we've all heard for 40 years is that the soil's not alive; it's just a matrix to hold plants. Well, that's just not true. It's a living, dynamic system. And so, right now in my retirement, we're working on an infield soil respiration system. This is a PVC tube that's in the ground about 6 inches, and we're collecting the CO2 out of that with this little handheld detector. So that's something we're working on right now. And to give you an idea, this is I had a bunch of those tubes buried, and so these are the results of CO2. And this is when it was fairly dry out, and then it rained. And I went out there about an hour after it quit raining and took the same results. And so you can see that there's this big jump in CO2, like right now. They don't wait around. When the water's there, they react. So the whole drying and re-wetting thing is a very important aspect of the biology of soil. This is another device that I just wanted to show you real quick. So this is measuring CO2 on an hourly basis, and heat and temperature and humidity and the interplay between all that. But the interesting part is the take-home message from this is the CO2 happens at night. The microbes really work at night. And that was shocking that we were seeing these numbers jump at night, because what that tells us is, they're working around the clock. This is not, they don't just start and stop. They're always doing something. And the other part of the Haney test that was different from the standard test, the standard soil test gave you organic matter, it gives you NPK, micronutrients, and that's all fine. But what it doesn't tell you is anything about the life of your soil, food in your soil for your microbes, and how they're responding to it. So we ran across this water extractable organic carbon. So the difference there, when you send a sample to a lab, if they do organic carbon, that's just combustion. So they take the actual soil, combust it, and capture the CO2 to measure the amount of carbon in that sample. What we did different is we extracted the soil with water and then ran organic carbon, because when it rains water, so that's the matrix soil uses. So we wanted to take a look at the organic carbon that was water soluble. And the literature said you use this half molar potassium sulfate to extract carbon from soil, which I didn't really like. Well, I started using water. And sure enough, we were getting out quite a bit more water, quite a bit more carbon with water than potassium sulfate, which is very interesting. Until you got to pH 7.7, then you got a little bit more out that way. So, and the majority of soils in the country are below 7.7. So we were missing all this carbon. Well, nobody was actually even measuring the water extractable portion, but so that was very eye-opening. We got that published finally after quite a few rounds of difficulty. So what we're trying to do here, organic matter is the house the microbes live in. The water extractable organic carbon is the food in the kitchen. So what we were after was, it's great that you have however percent organic matter, but we want to know what your food source is, because we were seeing a lot of soils that had the same organic matter and very different water extractable organic carbon. And so because that's kind of a sign of what your system is doing. What we're looking at, the food source that your microbes are thriving off of or not, and what you might want to be able to do to correct that. So looking down here at this water extractable organic carbon was really eye-opening. to give you an example, this is soil organic nitrogen and soil organic carbon. That's a combustion of actual soil. If you look at the axis here, you've got 0 to 5,000 part per million for nitrogen, 0 to 50,000 for carbon. When we do a water extract of the same soils, we're looking at just 1,200 part per million versus about out to 80 part per million. But they're both very highly related. So what this is a small subset of this. But this is the more important measurement because this is the food the microbes are using, and they're the ones driving the system. So this is why we want to use this. This is fine to use too, but if I had to pick between the two, I'd rather have this measurement than this one. Because here's the soil respiration. It's highly correlated with the water extractable carbon. So there's your food source that they're going after. And here's the relationship between water extractable organic nitrogen. This is also something that we're crediting as available in your field, this organic fraction, because it is. And the microbes, that's what they're using. They're breaking that down and releasing that to the plants. And so we can credit that. If your respiration's good, we can credit some of that to your nitrogen recommendation, so you don't have to put on quite as much. And that's really important. So I was guilty of all this when I was working for all those farmers. I mean, this is what we did. We plowed, if 5 weeds showed up in an 80-acre field, we were out there plowing it. So what were we doing? Stripping the skin off the soil, destroying organic matter. We had erosion problems. I didn't know any better. The guy I worked for didn't know any better. We just kept doing it. But how does nature do it? Nature grows a skin for living systems. Even, fish have scales. Plants are the skin for soil. That's the skin. If you pile up a bunch of dirt somewhere and leave it for 2 or 3 years, it'll be covered with something. I mean, that's the skin. That's the armor and the protection. So that's why the cover crops are so important. It cycles nutrients really well. We don't see any nitrate nitrogen in pasture, native ranges, because it cycles so nicely with grasses. It's diverse. It doesn't have monoculture. It seeks balance and is obviously sustainable. So these are the keys of the things that we want to do moving forward. And this is what kind of stuff that just really gets me. So around 1850, they were using a microscope. They could see these diatoms, little bitty cells in like pond water or something, and that was amazing. And here we are today. This is atomic force microscopy. This is a nanographene molecule. These are the actual bonds between atoms. We can actually see those now. Before, that was all theory. So look how far we've come with some of this science and technology. Yet in agriculture, we haven't come anywhere hardly in the last 50 years. So it was time to do something. So this is how we've always tested it as soil. As a non-living, non-integrated system, we focused on physical and chemical. We've ignored the biological part. We extract soil with chemistry the soil never sees. We measure the house and not the food. So we were wanting to change that, the way that worked. And I always ask people, are any of you walking around with these in your pocket? No, you're using these. So, this is 70s and 80s, 60s. Here we are now. Soil testing needs to move in this direction here. Great moments in evolution. I think that, here we are. Farmers are looking for something new that helps them. We think this soil testing is one tool in the toolbox that can help you get down the road better. So water is so important, as we all know. If it doesn't rain, it really doesn't matter. But the question that we always had is, when you go to the bank, do you throw your money at the window and hope some goes in? Well, no. Why do we do this with our rainfall? When we have fields that have diverse cover crops in them and it rains, we don't see this. The bare fields, that's just money going right down the ditch. That's just watching money go away. So water infiltration is really important. Water quality is also important. You know, you don't want this coming running into your watershed, into your drinking water. You want it to be filtered by the plant. I noticed that Evan had that one deal there. He said, well, you know, nutrient stabilizers. A plant's one of the best nutrient stabilizers there is. So water infiltration, very, very important. This is when I was at USDA and I had 200 acres of research farm, and I got my crimper stuck on the last round. And so I learned a lot about water infiltration with my tractor. It wasn't any problem infiltrating it. This was the last round of like a 100-acre field, and all the water had pooled on the, and boy, that was a mess. So here's what we're looking for. This is from the Illinois Chemical Society, I think, and these are just a nitrogen rate and corn with corn after soybeans. So they're increasing the rate of fertilizer. They're saying this is your optimum amount right here. This is your yield. So this is N rate versus yield. But what we're looking for, we don't, you know, we're not trying to correlate to nitrogen response trials. That's not what we're after. We're after that right there. We want to know how much NP and K your soil is giving you for free. We want that number right there. That's what the Haney test is looking for, is that one. We're not looking for nutrient response curves. That's been done to death. We want to account for this so that we don't have to put this much on here. Because how do we grow 100 bushel corn with no fertilizer? And why, if it, you know, at 100 pounds, we're not gaining all that much. At 200 pounds, you're hardly above that. And at 250, you're hardly above any. So this is wasteful right here. So we want to account for this and go from there. And this is some of the things that we don't usually ever see. This is that same set of data, N rate and pounds per acre, corn yield. But what I want you to notice is look at the variation. This field got 50 bushels per acre. That one got almost 160 with no fertilizer. We're putting 50 pounds on, we're at 50 and 200. Most people tell you it's impossible to grow 200 bushel corn 50 pounds of N, but yet there it is. So you get this tremendous scatter in these yields. But when we do these so-called calibration tests, so they're using that line right there. Well, you don't get to see all this scatter. So, you know, we have to really understand what we're looking at. Whether there's no such thing as our soil test is calibrated. Well, it's calibrated to something that it might have this much scatter on it. And all soil tests are that way. It's nothing new, but you know, to say that you got this absolute thing nailed down is just nonsense when you look at the whole data set. Here's another one. So this is a bunch of trials, corn trials, North Dakota, Minnesota. There's just no relationship between nitrogen rate and yield. None. Statistically, there's no relationship. It's even worse when you show the scatter plot. I mean, this is not a relationship. But you know, you got to start somewhere. But they call this, you know, how they calibrate their stuff. So my response is, in 2019, we had 8,500 square miles of dead zone in the Gulf. So apparently, you know, we have some calibration going on with over-fertilization to right there. And this is just unacceptable. This is money out of your pocket into watersheds, into drinking water, into the sea, into the Gulf. That's not, we've got to stop doing that. We want to get you guys where you're as efficient as possible. And we can't do that by doing the same thing we've been doing. So years and years ago, I don't know if y'all know Ray, but that's Ray, because he has sheep. So he was, you know, saying we don't have to be sheep. Well, all those years ago, I'm amazed at the soil health movement so far, just because, you know, when Ray and Gabe and Dave Brandt and I were running around, and Jay Fuhrer talking about this stuff 10, 15 years ago, we didn't think, you know, it'd ever see the light of day, but here we are. Things are changing. So this test is basically asking you, asking your soil, this is the approach that's so different. We're asking your soil to tell us what's going on. We're not getting the soil in the lab and beating it up and say, extracting it with harsh chemicals and trying to rip out whatever we can get out. We want this soil, we want our testing to be as passive as possible so that the soil can tell us what's going on. So these three questions are the key. What's your condition? Are you in balance? What can we do to help? So this is what we're asking the soil, and we want these results to tell us the answer. Because this is an incredibly complex living system. And fortunately, this microbe take in O2 and give off CO2, we can measure that pretty simply. But that's very important. That's the kind of the cornerstone of the whole test, because that is a biological test for your soil. So the soil responds after rainfall in the field, not how it responds to 30 to 60-year-old lab methods. That's not what we're after. We're trying to mimic as best we can what's happening in the field, because that's, where the action is. It's not, you guys aren't growing 1,000 acres of corn in a lab. It's in your field. So we want to try to mimic that as best we can. So for example, for phosphate, the standard test, they use a couple different machines and up to 7 different soil extractants, which give you different numbers. We also run both machines, but we also integrate my extractant, which is mimicking what a plant root does. But we also look at soil respiration, organic CDN ratio, phosphorus mineralization potential, iron, aluminum, calcium. All these are factors in how available your phosphate is. So we're trying to integrate this approach with many different measurements to be more accurate. Because, a plant-based root extractant is what I was after. And so these roots right here will they'll leak out organic acids. And there's some very similar ones across the board for all plants that are very similar. And that's what we put in the extractant, because this is where the ball game is these roots interacting with the microbes and solubilize the nutrients, based on these organic acids, and they can change those on the fly. I mean, it's a dynamic system. So, they can decrease or increase the strength of the acids that they drop in the soil to get what nutrients they need. And that's, completely ignoring the fungal component and what they do. So that was a step in the right direction, I think, with this plant-based soil extractor. Because what does a plant root really see? Well, that's what it sees. It sees, enzymes, root exudates. It doesn't see really acidic and alkali solutions that we use in the lab, for 40 years. This is a liquid sun. So this is plant root, and there's all those organic acids and various things that they're dumping in the surroundings. And the interesting part about that is these are all carbon based, these organic acids. So they're pumping food for microbes around that root. Microbes come up there, use that, release some nitrogen, which the plant, takes up. So it's a complex system, but they work together. And it's been evolved for a gazillion years. So we're just now getting to see some of this. So this is an interesting little graph. There's I believe 4 soils in here from pH 5.5 to 6.5. And what I did was change the pH, extracted pH. So how strong the extractant was, more acidic and more alkaline. So these soils are about 5.5 to 6. So this is really your right answer, is right in here, about 40 part per million. But if you use a very harsh extractant like Malic 3, now you're extracting these. Now it's 80 or 90. Or if you use something like Olson, which is with pH 8.5 buffer, you're going to get this number, about 10 or 8 or 10. So you can get these wildly different numbers for the same soils depending on the extractant. And what we were trying to do with the extractant we developed was get it in here where the soil actually operates. Because you're running over the soil pH here and you're driving the pH way too low. And so we got this published, and that was pretty eye-opening also. I'm going to move on past some of this. So nitrogen, again, currently we just test for nitrate nitrogen. We use 2 molar KCl. You'd be shocked if you found out how many, where I was, how many soil testing labs around the country don't test for nitrogen at all. That really surprised me when I looked into all that in graduate school. What we do is we measure ammonium nitrate just like standard test, but we do this water extractable total nitrogen. Again, we look at soil respiration, organic nitrogen, seed-in ratio. We have a calculation called MAC-WEON, N-min, and a water extract. So again, we're looking at all kinds of different things to help understand what's actually going on. We've only tested for this for 50 or 60 years, nitrate nitrogen, that's it. And all these other compounds are in water solution, are available to microbes and plants, and we've ignored all of them. Now we're starting to bring those back into the system. This was the game changer, that little white box right there. I think this is 08, 07, 08. This company came out, this is a carbon analyzer for water, which is what I was using. They came out with this. I begged my boss to buy me one. It took a month of convincing to get him to do it. And I put this in myself. And this is a nitrogen component analyzer. And this changed everything. Because now we can measure total nitrogen in a water extract, take the same sample, put it in a different instrument, measure the inorganic. So the difference is organic. So that's the pool we've been missing for all this time. And we would have never seen it if it wasn't for that little piece of technology that showed up. So the first 6,000 samples I ran through the lab at USDA, we saw that we were getting about 36 pounds of inorganic nitrogen, and we were missing this. So we were completely missing this, not accounting for it. And that was just eye-opening. So this is a huge difference. So, we want to be able to tell you if you're usually putting on 200 pounds or 250 pounds of nitrogen to grow whatever bushel of corn, if we can show you that you can maybe get away with 180, 170, maintain your yields, that's just money in your pocket. And it's sitting there. And all we need to do is analyze it correctly so we can see it.
Hey, Rick.
Yeah.
We got a question here.
I'm just curious, when you're measuring the organic nitrogen, how much does that vary over time? Is part of the problem you're taking a snapshot, and is that a very volatile kind of measurement depending on what state the above ground plant life, et cetera, is? Well,
this is from soil. That's actually a pretty stable measurement. Okay. And it's not a direct measurement. I need to make that clear. So we're doing that by difference. So the sample goes in the T&N combustion machine, and so we get total nitrogen in that water extract. And then the same sample goes and we run it for nitrate and ammonium. And so it's a difference. So we take the total minus the inorganic, and that's your organic pool. And interestingly, one of the first things that you see, and another great thing about that is when you start moving into a cover crop system or a regenerative farming system or whatever, one of the first indicators to really show us something is that ratio of organic to inorganic nitrogen in a soil. That is really important and very sensitive. So when we started out the research farm all those years ago, we were running these measurements. And so we had usually twice as much inorganic nitrogen in that soil as we did organic. So as we started doing the cover crops and backing off on the tillage and moving forward with that, within the first year, we saw that start to change. And after the second year, we had as much organic as we did inorganic. And in the third year, we had more organic than inorganic. And so that's a very sensitive measurement for, are things moving in the right direction? which brings me to cover crops. I think the plants are so important. I know that cover crops aren't going to work in every system because some folks are so dry. I mean, without water, nothing happens. We all know that. But cover crops are so important because they give life to the soil. They give life to the microbes. They make everything work better. And we've seen this for years and years and years and years. The key is to find out what cover crops work in your area, because not they're, they don't all do the same thing in the same place. So we've did a lot of experimentation with all that, and we had some success and we figured out some things, but then I retired. I guess not, but this is my little slogan: plants fix dirt and make soil, because they do. Because without plants, we don't have soil, and vice versa. So they're the drivers. They're the ones that are going to understand what's happening. These are microorganisms around these plant roots blown up. This is what we want to understand, but we want to be able to marry the right plant to your soil. We have this complex system that they use. I mean, I like to show this because it's just so mind blowing how difficult it is for a plant to do things. But this is, energy. But the fun part is there's that CO2 right there. You can see CO2 in these places, various places. So every time the ATP cycles, you get 2 CO2 molecules out. So the soil respiration method is actually also a method for the energy in your soil. I mean, it's just directly applicable that, yeah, you have this much CO2 coming off. We think you get this much nitrogen from it. Here's how much it likes your food. There's a lot of that stuff, but that is also how much energy you're capturing in your soil to drive the system. So it's not just respiration, it's a measurement of energy and biomass and how they're working. It's an important little measurement. And so, this is what we did in Oklahoma when I was working on all those farms. We plowed everything up just like this. It sat like this most of the year when we didn't have wheat planted on it. And, I never stopped to think, is this good or bad? And, I never even thought about it. But, which one of these fields is capturing solar energy? Well, this one is. This one's not capturing any, zero. And so if you've got a living plant out there, you're capturing energy, you're capturing carbon. This is just a good thing. We did this little test. This is sunflower roots down here in Texas, and we pulled several sunflower plants, they're native to Texas, out of the ground, and we shook the roots off of it, shook the dirt off of it. So what came up with still stuck to the roots, we shook that off into a bag. This is a more detailed look at how delicate looking those roots are, systems are. And we did the same thing with some sorghum roots. And so we pulled enough plants to get a sample. Pull the plant, shake the dirt off of it into a bag. We pulled enough plants to get a sample. So we took those in the lab and we ran, 1 day CO2 on it. We had a bulk soil. This is what came off the sorghum. This is what came off the sunflower. So the sunflower respiration was huge compared to the other two, because this is a native plant. So those soils recognized that sunflower, like that sunflower. They weren't too thrilled about the sorghum. It was barely above the bulk soil. But the soil health score was bigger here. I mean, we just saw this trend all the way across. More food, higher respiration, less food, less respiration, and then, so this was a very exciting thing that we did. I did a big study with green cover seeds where we looked at a whole bunch of different plants. And I think in the future, we might be able to use this type of system to let your soil pick out the cover crops that'll best work in your environment. That's where I was kind of headed with that. So this is the stuff we did with green cover seeds. And just to give you an example, we saw some pretty shocking results. And what I did was put the top 5 and the bottom 5. So for these mixes, so Egyptian wheat, for example, had by far the highest respiration for CO2, and popcorn, sorghum, fava beans. And then this pollinator mix had really low, well, compared to, that's fine respiration, but it's kind of low compared to the others. But here's the fun part about this. So if you need to up your respiration, you might want to pick some of these. If you've got plenty of respiration and you need more nitrogen, then you might want to pick some of these for a cover crop mix. So that's what I was headed to, trying to let the soil tell us what cover crops it wanted to pick out. So this is how we were going about that. So, and for example, this is potassium. Here's the pounds of potassium, lower here, higher here. Now, this is what's interesting about this is if you wanted, these might be lower because sun hemp uses more potassium. Triticale might not need as much potassium. So we have to think about this, in a different way. If the potassium is piling up in this soil, they might not be taking it up, whereas these might, because this is all done in the same soil. It's just different plants. So, this might be, if you wanted to pull potassium up, sequester it, and put it in a plant that would later fall back in and get, mineralized, then you might want to pick these. If you got plenty of potassium, you might want to pick these. So, it's just that kind of thinking. So I did more, testing, and I grouped them. Here's your legumes, grasses. The grasses were just slightly higher than the legumes as far as respiration. Brassicas were the lowest. Then here's your broadleaf and your mixes. So that was interesting. So that was respirations. So we're grouping them by, legume, grass, brassicas, and broadleaves. And this is the food source, the water extractable stuff. The mix had the highest water extractable carbon. So that was very interesting. I'm just showing you that stuff pretty quick, but so here's some of the stuff that I do with Lance. And say, I don't know if y'all have run PLFA analysis, but I've been looking at that for about a year now. So this is kind of interesting. So this is your functional group diversity, how diverse your microbes are, fungal to bacterial ratio. So as your diversity increases, your fungal to bacterial ratio gets better and better. So that, we that's what we try to look for in this analysis is trends. Protozoa don't like inorganic nitrogen. That's pretty clear from this graph. As the protozoa, as the nitrogen increases, the protozoa go away. And so I have much more data than this. It's an older slide, but that's kind of interesting. That that interrupts that system if you got way too much nitrate nitrogen out. This is the water extractable organic nitrogen. They don't seem to mind it too bad. So, again, very interesting. They prefer the organic nitrogen to the inorganic. This is, so functional group diversity. So Lance tells me that around 1.4 is an excellent functional group diversity for PLFA. So I looked at that versus the Haney test for soil respiration. Sure enough, at 1.4, you can see here comes all the respiration. So it's interesting to see both of these very different tests kind of telling you the same thing. This is fungal to bacterial ratio, about 0.2, he told me. There it is. I just found that to be fascinating. So these are some of the stuff that we're working on now. This total nutrient digest has really been interesting. When coupled with a Haney test, we're looking at that pretty closely. This is something that I got started back when I was at USDA. I had farmers asking me, well, what's this soil health score mean? And I said, well, because they'd send in one sample. Well, I asked them, so I started telling them, pull samples from your fence line and then from your field. And we were using the fence line as a baseline because they weren't farming that. And lo and behold, that's what we saw. The field was usually lower than the fence across the board. So that was kind of a benchmark for them to see, what that soil was capable of. And that started us down the road of doing this. So this is a depth analysis. So this is a 0 to 6 and 6 to 12. So you would pull a 0 to 6 sample, your probe or your auger or whatever, and then you go right back down that same hole and pull out a 6 to 12, put them in separate bags, send them to the lab to get analyzed. And we can really see the impact of management on the difference between those two depths. Both depths get run for the Haney test, but we can look at the amount of carbon that you captured in the top 6 inches compared to the bottom 6 inches. We can look at if you're farming regeneratively or not, where you're at, what kind of progress you're making. I mean, it's just excellent test. And so we've got quite a few. We've got about 1,000 of those in the database right now, and that's very interesting. And I think in the future that'll become more important because it is a direct measurement of your management impact. This is as that difference in 0 to 6 and 6 to 12 goes up, then these are the dollars that you might potentially get per acre for a metric ton of carbon equivalent. So you all heard about carbon markets. Well, this is what I think this would be a better way to do it, to measure this dynamic fraction along with the organic matter. And so we've been talking to a lot of companies about this, and hopefully somebody will see it. So I think this is a more fair way for farmers to get paid for carbon based on their management decisions. We also have this little test. It's kind of a water quality index. And so this is, we call this one the P water quality index, and down here's the N index. So based on these calculations, you don't want your number above 8 because you might have potential issues around or under your farm. And so we have some folks that are kind of interested in this. And these are calculations that come off the Haney test that we're going to be able to put out if people want them. And then this one's a soil health calculation versus nutrient density index. So you hear a lot about nutrient density in food and how important that is. Well, we've got this test. This is a 0 to 6 Haney test. We can calculate your organic nutrient density index from that, because I don't see how you grow a nutrient dense food without a nutrient dense soil. So we're trying to expand the information that you can get from this type of testing, because I think there's a bunch of markets going to be opening up for this kind of stuff, and we're trying to get ahead of the game here. This is PLFA, so this is the total living biomass. If y'all have ever done that, I've come up with a score called the PLFA health score, soil health score. And so this leans more towards the fungal component and protozoa, and looking at fungal to bacterial ratio. So we're kind of like the Haney Soil Health Score. This would be a PLFA health score. So we're thinking about incorporating that, if Lance decides to, if you get a PLFA analysis. And this is total nutrient digest and Haney test for organic carbon, organic nitrogen. So this is the amount of organic nitrogen that's extractable based on your total nitrogen. And same thing for carbon. These are really going to be interesting. We're going to do this for pretty much every nutrient, and to see that, if you think you're mining your soil nutrients, we can show you, yes, you are, or no, you're not, you're going to be fine. This should help reinforce the fertilizer recommendations as being dependable, because we're going to start doing some of this stuff. So these are the things that I've learned, that there are jerks everywhere. I've learned how to keep my mouth shut, sort of. I've tried to be real honest and found out, it scares the crap out of people. When I got out of grad school, I interviewed all over the country and got a job offer from New Zealand and moved 90 miles. So don't be afraid. And always remember this. This is something that I'll never forget. That's a piece of rusty wire in my shop. And this is a little bug that puts its little eggs on that thing right there. I mean, my God. Like, I took that picture because it's like, how did this happen? Why would a piece of rusty wire be the perfect substrate for this little insect to put its egg? anyway, nature finds a way. All we have to do is work with it as best we can instead of working against it. And finally, I know y'all have heard about plant-based meats. I don't know what you think about them, but I think this one should really take off. Because that's a plant. This is a plant-based meat. Can't believe the people I've had to tell this to. Anyway, that's it.
Let's hear it for Rick. Thank you, Rick. Anybody got questions for Rick?
Hey, Rick, how reliable are your nitrogen and phosphorus numbers that you show on your test? Because maybe you show 57 pounds of nitrogen. Is that pretty accurate? Can people bank on that?
Yeah, and I'll tell you why, because that's conservative. I am very keenly aware, after working for those farmers for all those years, you know, how scary it is to not have enough fertility out there. So the numbers that come out of the Haney test, you can bank on because they're conservative. We don't, for example, we do a total nitrogen extract. That's just a point in time nitrogen extract. There's going to be, I did a study where I extracted 60 soils 5 times in a row, extracted them, dried them, extracted them, dried them, extracted them, dried them. The organic carbon and nitrogen kept coming out. So we know there's more there than we're accounting for. But we intentionally made that set of recommendations conservative because I know that farmers don't ever want to be short. So yeah, if it says you can back off 40 pounds of nitrogen, you can. You could probably, well, and I'll give you a quick example. Dave Brandt called me one year and he said, well, your test doesn't work right. I said, why is that? He said, you told me I could back off 40 pounds of nitrogen to still get my 200 bushel corn. I said, okay. And he said, well, I backed off 90 and still made it. So why do you underestimate what I could back off? He thought that was really funny. But then I explained that to him. And so, you know, yeah, if it says you can take that off your recommendation, you can. And just trust me, that's conservative.
It makes me feel more comfortable because when I'm out there in the field advising producers and they see that number, they have a little skepticism sometimes. Like, does this guy know what he's talking about?
Well, yeah, but see, that's why I showed that if you only test for nitrate nitrogen, I had one that came across Lance's lab the other day. So if you, in this field, it had 3 pounds of nitrate nitrogen, and they were going to grow 200 bushel corn in it. So the recommendation called for 200 pounds of nitrogen. Our test showed he had 80 pounds of nitrogen in the organic fraction. And, completely missed, you completely missed that. Because if the organic nitrogen wasn't being utilized, then before we had fertilizers, nothing would have ever grown, would it? And that's the mentality we've been operating off of, is that, well, if we don't add this nitrogen, nothing will grow. That's just not true. I mean, I'm not anti-fertilizer. I'm anti too much fertilizer. So, yeah.
Okay, my next question is on your MAC percentage, your microbial available carbon. Can you expound on that, please?
Yeah, that is just your respiration divided by your food. And what I like about that little calculation, to me, is that what that is your microbes telling you whether they like the food you're giving them. So if you have a high MAC, above 50% up to 150%, that means they really like the carbon they're seeing. If you have a low MAC, which means you've got X amount of carbon and your respiration is low, then you might want to think about the carbon inputs that you're giving it. You might want to change that. That to me is about the quality of the carbon that the microbes see, because they eat carbon, poop out nitrogen, and so we want to get them going. So that's an important measurement.
Well, have you changed the carbon just to check that philosophy? To show there's changes in the number? You were just.
Oh, yeah. Yeah, when we was at when I was at the research station, I had 200 acres to play with, and we had all these diverse cover crop mixes, and in this part of the field and that part of the field, and yeah, you could see that change. That's really kind of how I stumbled across that, was playing around with that little calculation right there. Yeah, if you were heavy legumes one year and you went more heavy grasses the next year, maybe brassicas, you'll see that switch.
Our soils here in Iowa, is there an optimum time of year to take that test? Are we worried about soil temperature that dramatically when the test is taken, or is there other?
Well, the test was originally developed to look at NPK. So it was developed to, take samples before you fertilize so that we could, maybe have some reductions to still maintain your yields. But the biggest thing about the soil testing is you don't want them frozen. I've run a lot of samples around the years, and, we get samples in the lab that were, more like soup than soil, and that's no good. And we'd get them, they'd take them when they were frozen, and that doesn't work well. So if your soil temperature is above freezing, then they should be fine. But you can take the test anytime you want. It depends on what you're interested in. That's why we give the NPK and all the recommendations, and then all the soil health information, because you get both on the test.
Is it important to take the test at the same time every year?
I think that would be ideal, but as you all know, we don't live in an ideal world. So, you take them when you can, and try to be as consistent as possible, but that doesn't always work out.
So along that same line, is if I picked a spot and took that soil sample, let's say the 1st of June, every single year, same identical spot, and ran that test, what would be your anticipation of the range of test results that would be back? Or another way to say it is, how consistent could that be?
Well, our biggest thing is that we take very small samples from spots. And so we want to take a bunch of samples and composite them, because you want to look for an average. And will it change? Yeah, it'll change. And we had a guy, I'll never forget, this guy called me. He said, well, we've been sampling every 2 months for a year now, and the numbers are changing. And he was all upset. And I said, thank God. And he said, well, why? I said, because it's a diverse system and we have a diverse test. I said, we should be seeing those changes. But there's a Continuum Ag. I don't know if you know Mitchell Hora, but he's got some great information. He sent me samples on a weekly basis for a long time when I was at the lab, and I think he's still doing that with Lance. He's got some great information. So does Lance on the fluctuation during the year of when that, what that test showed. But if you're sampling the same field, say you got 80 acres and you pull 10 samples out of it, deposit them, it should be in there pretty good. It should handle it pretty good.
Hey, Rick, if we increase the fungal to bacteria ratio, are you seeing some major fast changes out there in all the soil health? Let's say we had 0.3 and we inoculated the soil. Now we're up at 2 to 1 on fungi to bacteria. Are you seeing some significant changes?
That's a really interesting question, because one of the things, this is part of what I've really enjoyed working with Lance, is because I get access to those. So when I look at samples that have had PLFA and Haney done on them, it's very fascinating, because we get a high fungal to bacterial ratio. Not always, but by and large, the respiration comes down. And that was really interesting, because I think what's happening there is the system's becoming more efficient. When it becomes more fungally leaning towards the fungal component, it becomes more efficient at moving nutrients. And we kind of see that, especially with nitrate, because nitrate tends to go away when the fungal component really increases. Does that make any sense?
Yes.
No.
Now, do you also see carbon levels increasing when you've got a higher, more fungal dominant environment?
Yes, and so the MAC that somebody had talked about, that when we see high fungal, the MAC tends to change. The MAC tends to come down a little bit, which is interesting. Because bacteria are really, they're fast at consuming carbon. And so when we see super high respiration and low WEOC, which would be super high MAC, that's probably bacterially dominated. So as fungi become more prevalent in soils, that whole system seems to stabilize a little bit, equalize. The nitrogen worked out well, but yeah, we have a lot to learn.
So then on the high fungal dominant, you see the WEOC numbers going up.
Yes. Yeah, and usually we'll see phosphate drop a little because they seem to be more efficient at delivering phosphate to the plant. And there was another weird one that that's what I have, I look at thousands of samples, and so there's no absolute in science, and regardless of what anybody tells you, we're looking for trends. So the trends are what's important to understand, not because you can find samples that'll tell you completely the opposite answers. I can't tell you how many times I've seen a PLFA set of data that just looked terrible, and the Haney test stuff didn't look too bad. And then if you looked at it side by side, what you were seeing was it was a bacterially dominated system. That's why your respiration was high, and if you look at PLFA, I'll tell you this, protozoa is the first thing I look for on a PLFA result. I want to see if there's protozoa present, because a lot of the times that says 0, and that tells you something about that soil right away. And I also have another calculation where we look at respiration divided by the total biomass. So we want to know if that total biomass is very active, is a big biomass that's kind of active or real active, or a low biomass that's super active, or so we're trying to look at all these different things, and hopefully Lance is going to set up another website that there'll be a bunch of additional calculations for all these tests that'll help us understand this a little better.
I was just curious, I'm operating at a more basic level than some of what you're talking about. So for my brain, if you could go, from everything I've known, that you do want to up the ratio of your fungal to your bacterial. So could you go into what kind of things you would look for in this respiration part to know what you're aiming for in terms of respiration in a more fungally dominated soil system, and what kind of things I would turn my attention to? And also, what sources would you turn me to learn more about what you're talking about so I can understand more of it?
Let me see if I got your question. You're kind of breaking up on me there. Are you asking what do you do to increase your fungal biomass?
No. I was asking, from everything I know, that one is trying to do that. So if that is the premise, that we do want to change that balance and make it more fungally driven, within that, what am I looking at in terms of my values of the soil testing to see what kind of respiration I'd be looking for that was helping me to get to that? How do I make sense of those respiration numbers, given that they're changing with the fungal balance and the bacterial balance, but also what kinds of sources would you turn me to look at so I can make more sense of what you're saying?
Okay, so the Haney test won't give you, any of that. Haney test gives you respiration. So you have to have PLFA to look at fungal bacterial, right? Or some of the DNA sequencing they're doing. So you'd have to run, both of those, a couple of those tests to look at those, because PLFA doesn't have respiration. Haney test doesn't have any, functional diversity and all that kind of stuff. So you'd have to do a couple of tests to get that information. Sources for trying to understand that. Right now, we're working on 2 new interpretation guides that are going to be up on his website pretty soon for Haney test, PLFA, total nutrient digest. You might look into some of the stuff like Trace Genomics is doing with the DNA analysis as far as sources, papers. I mean, just Google. I mean, we have Google brains now, so you might just Google, fungal bacterial ratios and what do they mean? That's what I do. And you can run across an enormous amount of literature to answer those very questions.
Next question, do you have any publications or anything that recommend different mixes of cover crops ahead of different crops? I see you've done some experience, you like the mixes, but depending on what crop we're going to be putting in, do you have any recommendations online, or where do I get?
No, places like Green Cover Seeds and other places, they have pretty good information on some of their websites. Some of these cover crop companies, and I think an interesting point that you're bringing up is you don't have to have a 37-way mix to be diverse. If you have a limited budget, if you can do a 2-way mix, just do something. Like ryegrass and Austrian winter peas, like for a fall mix, work really well together. Buckwheat is great to get fertilizer jump start or phosphate jump started. It's kind of an intuition type thing, what you're after. And there's getting to be better literature out there about what these plant species do by themselves. And so I would just try to find some of that information. I don't have personally anything like that available.
Again, part of the reason why I'm asking, I've already been under the understanding putting cereal rye ahead of corn and letting it grow too tall or too advanced before you put in the corn, you'll actually have a yield reduction on your corn, is what they're seeing. And that, that's the biggest thing that scares me. And
oh yeah, I can understand that. But here's the fun part. The reason you have a little yield drag. So remember we were talking about nutrient stabilizers, Evan said earlier, and the great thing about cereal rye is it is very good at sequestering nitrogen, nitrate nitrogen. So when we see a field that's planted with cereal rye, let's say it's 2 foot tall, you go out there and pull a sample, you won't find any nitrate because it's all sucked up into that plant. Now the trick is getting that plant back on the ground, and if the microbes start chewing on it, they will release that nitrogen back, but maybe not in time. And so I think you're right. You don't want that cereal rye to get, out of hand and cause you a yield drag. But if you kill it at the right time so that it can get in the ground and the microbes start chewing on that, then, we used to actually out at the research farm grow cereal rye, and we'd plow it down. And it was a whole timing thing because we'd plow it under in our conventional till plots. And we could tell it was about 3 to 4 weeks before we really started seeing it come on. Because we didn't put fertilizer out because we were trying to look at the effect of cover crops. And so that was basically a slow release fertilizer. And, so I understand what you're saying. You don't want to do that. So you were fertilizing those also after your cereal rye?
Fertilizing also after the cereal. I haven't done it. I haven't done the cereal rye. Or least I did it one year and never got it in time in the fall to get enough growth by the time I got any advantage out of it in the spring. But yeah, I fertilized it.
Yeah. Well, and here's the other thing. I have always, the farmers that I used to work for, you know, it's just like, you try it on 5 acres. If you got some little field somewhere, try it on that. You don't have to do the whole farm. You know, let your field be your experiment. Let it be your lab. I mean, pick a field. This guy I know in Oklahoma, he's got a 7-acre field next to his house. And I said, there's your experimental right there. Let it teach you. You teach it, you know. These are the kind of things that would be terrific if we could get more farmers that were doing their own kind of research on their own farm. I mean, you could put steel rye out and let it get to different stages and then plant corn in it. It'd take you a little time, but it'd be worth the investment in time. But you could look at that, and then you could come back with, you know, 100 pounds of nitrogen, 50 pounds of nitrogen, 150 pounds of nitrogen. You know, you could answer that question pretty easily on your own farm, looking at your own stuff.
Well, the biggest thing, to my understanding, the sooner you can get that cover crop in the fall, while that crop is still growing, to get some good grief. But to wait till after you harvest the soybeans or the corn and put it on, for a lot of years not getting enough growth there to really get much benefit. There'll always be some, I think.
Yeah, because you know, it's funny because, you know, here we are down in Texas, and it's a very different ball game. We could, you know, plant cereal rye in, you know, December, January. We had to, but yeah, up there, that's a whole different ball game. That's right.
With instead of plowing under, we've experimented with critically vetch and field peas with flail chopping and then rotating about 2 inches deep and then planting into it. And we were pretty happy with that. So broke it down into small pieces.
Yes, we bought a you know, a shredder, 20-foot shredder, and I was using that. Dave Brandt came out there and chewed my ass out, and then I somehow acquired a flail shredder, and that did work better. I agree with that. It's tinier. You can, yep, that's way better.
You mentioned that on a hay field, we look at the protozoa. Why?
Oh, any field. Protozoa on the PLFA test. So protozoa eat bacteria and poop out their guts or their nitrogen. So when you see good protozoa activity and you look across there on the Haney test, then look, you have this higher organic nitrogen rate. So that's almost a direct comparison. It's interesting in the winter. So the samples that are coming in now, you hardly see protozoa because it's cold. People are taking samples when it's fairly cold, and that does affect the PLFA test somewhat. Well,
Any other questions for Rick? Tell you what, Rick, we're very honored that you took the time for us here in Marion, Iowa. We really appreciate it, the knowledge that you've shared with us on the Haney test, but also just how to make it practical as farming as we can on our acres. So we really appreciate it. Any more questions for Rick at all?
Yeah, Rick, I just got one question. Are you making any low interest loans?
No. I wish. Hey, I'm on Social Security now. I mean, you know, Lance can't pay me much because then it ruined my Social Security.
Well, good luck with that.
Yeah. Yeah,
Well,
that's one thing. that's one thing we'll clear up. I retired a year and a half ago, and I don't remember where we were, wasn't too long ago. And this guy comes up to me. I think it was when we were in Iowa at the big soil health event. And he said, "You must be a rich man." I said, "Why is that?" He said, "Well, didn't you develop a Haney test?" I said, "Yeah." He said, "Well, you didn't make any money off that?" And I said, "No." And he looked at me like I was an idiot. He said, "There's something wrong with you. You weren't very smart." But there was a lot of people out there that thought, I don't make a dime. That's government. I work for the federal government, and that was a service that we developed, and that should have been free. So I think that was right. But that was a funny moment.
We appreciate what you do.
Well, thank you, Rick. Thank you very much.
Yeah, thank you guys for listening. Gets lonely here in my barn.
Well, we're always here for you. We'll set up another call sometime. So.
All right.
Thank you, Rick.
Thank you.
Thank you.